All right, welcome everyone to the first laboratory of the Introduction to Statistics and Data Science course. I'm Makami here, and today we'll be diving into the basics of R and how to use the IDE called RStudio. Now, if you haven't installed RStudio, I suggest you check the very first introductory lecture titled Lecture 0 for more information on what we'll need as part of this course. I'll provide it in the card above right now. So if you haven't installed R or RStudio, please watch that video first and do that before you continue on with this lab. All right, so now let's have a look at some of the basics of RStudio in terms of its layout. At the top here, we've got console, terminal, and jobs tabs. For most of this course, we'll be focused on using the console tab. So don't really worry about these other two for now, unless you're curious. On the right-hand side here, we've got an environments tab, history tab, connections, and tutorial. Most of the time, again, we'll be using the environments tab, just so we can see things like variables we declare, data sets we import. They'll all be visible here once we get to it. And then on the bottom right here, we've got some extra tabs like files, plots, and packages. We will most likely be using files and plots as we dive further on into this course. So that's just a general overview of the layout of RStudio. Okay, so let's have a look at some of the basic operations that we can do in R now. If you click into this console, you'll notice that you've got a flashing little vertical bar here. That just indicates where you can start typing. So you can do some very simple scripting things like 1 plus 2, and then you press enter. You notice that it performed the operation 1 plus 2 equals 3. You've got all the basic mathematical operations as well, like subtraction, 1 minus 2 gives us minus 1. You've got multiplication, 1 times 2 gives us 2. We've got division, 1 divided by 2, that gives us half. And we've also got exponentiation, so 1 to the power of 2, and that gives us 1. Keep in mind as well that R also respects order of operations. So if I go 1 plus 2 times 3, if I don't add any brackets, it's going to do 2 times 3 first, which would give us 6, plus 1 to give us 7. We can also add brackets if we want to perform certain bits of operations first. So with the above example where we had 1 plus 2 times 3, we didn't add any brackets, so it just respected the order of operations as we know from mathematics. But if I was to go open bracket 1 plus 2, and it automatically closed bracket for us, multiply that by 3, it will now do whatever's in the brackets first. So 1 plus 2 will give us 3, times 3 will give us 9. The next thing we'll dive into is how to declare things called variables. Now, they're very similar to mathematical variables. They're just meant to represent a value or act as a substitute for a value. So if I go into my console here and go type a equals 7, we see here now in the environments panel, we have the variable a and the value we gave it was 7. So now if I type a into the console and press enter, it will spit out the value that the variable stores. Variables are also case sensitive as well. So if I go capital A now, you'll notice that it says that we're given an error. The object capital A has not been found. So if I type lowercase a again, you see that because we haven't cleared anything, it just brought back this value. So be aware of that. Variables are case sensitive. Similar to what we did with the numbers above, we can also perform operations on variables. So now if I declare a variable b equals 4, so if you look on the right hand side now, we've got a is 7 and b is 4. We can do mathematical operations on those. So if I go a times b, it will give us 28 because it's 7 multiplied by 4. We can do exponentiation, so a to the power of b, and we get 2,401 because it's just doing 7 to the power of 4. So what we do with just raw numbers here, we can also do on variables as well. We're not restricted to single letter variables as well. We can use words to represent variables as well. So if I type the word weight equals 80, if you look on the right hand side now, we now have a variable called weight and it's been given the value 80, which is what we assigned here. There are some restrictions with how we declare variables as well. For example, we can't start a variable name with a number. So I can't go 1 weight equals 80. It'll spit out an error saying unexpected symbol in 1 weight. We can put numbers within the variable, but we can't start it with a number. So if I go weight 1 equals 90, that's perfectly fine. As you can see, we have a variable now, weight 1 equals 90. We can even put it in between characters in the variable name, though I wouldn't recommend it. So if I go WE1GHT, equals 100. You now see we have a variable here on the right hand side, we1ght equals 100. Like I said, I would not recommend it because it makes typing it out and remembering very confusing, so just don't do it. Although you can be quite flexible with how you declare your variables, there are some practices that you should adhere to so that if you were to give your code to someone else, it would make it a lot easier for them to read what you're actually doing. So for example, with the example I gave here with weight, but with the I replaced by a 1, that's definitely a bad practice. If you want to put two words together, for example, you can have tutor weight equals 100. A good practice here is to what's called camel case, where the first word is all lowercase, and then the beginning of the next word has an uppercase character for the first letter. So tutor weight equals 100. Another practice you can do is you can do underscoring. So tutor underscore weight equals, say, 200. That's also acceptable. R also allows you to use a period instead of a hyphen. So you can go tutor dot weight equals 300 as well. Internally, this dot actually represents something else, but I'm not going to dive into it too deeply just to keep things quite clear and concise. But just be aware that there are some standards and best practices that we have when it comes to declaring variable names. It's something you should just fiddle around with yourself and find what's more comfortable for you. One other operation that will be very, very handy is creating a set of numbers. So if I go variable letter F equals C, and then open brackets 1, 2, 3, 5, and whatever numbers we want, and I press enter, you see now on the right hand side, we have a variable F, and it's actually a collection of numbers. The numbers 1, 2, 3, 5, and 11. And if I press F, it actually gives me the set of numbers that we declared earlier. Now, the reason why creating a set of numbers into a variable might be useful is if you need to calculate many, many values or use certain values in a formula or an equation, instead of typing each of those values out individually and storing them as individual variables, you can just store them within one variable and the operation will kind of do them element-wise. So let me go through an example of that right now. So let's say I wanted to double every single number between 1 to 10. So I'll create another set of numbers, which is also known as an array. I'll use the variable F again. So if I go C, 1, 2, 3, 4, 5, 6, all the way up to 10. Oops. As you see here on the right hand side, because we reused a variable name that was declared as something else before, it overwrote that variable value and replaced it with what we declared just now. So now if I type F, we have an array of numbers between 1 to 10. A quick shortcut, by the way, if you want to just do something like this, numbers between 1 to 10, increments by 1, you can just do this instead. So F equals 1 colon 10. And this is basically saying, give me a set of numbers between 1 and 10 inclusive, and the difference between each element is 1. So now if I press enter, and I press F again, you notice that we get the exact same thing. Now let's say we want to double each of these numbers that we declared in the variable F, all the numbers between 1 to 10. So instead of typing out each of these numbers individually, you see now that we have them in this variable. So if I go something like 2 star F, you notice here that it's basically given us F, but every single number was multiplied by 2. So this scalar operation here, 2 times the array, it's just gone ahead and distributed that multiplication of 2 to each of these elements here. You can also do things between two sets of numbers or two arrays. So let's say I have one array called F, and it's just going to be the set of numbers 2, 4, and 6. And I have a second variable G, which is an array of numbers 1, 3, 5. Because these two variables are representing sets of numbers and the set size is the same, as you can see, F has 3 elements, G has 3 elements. If I go F plus G, it's going to be doing element-wise addition. So it's going to go 2 plus 1 equals 3, 4 plus 3 equals 7, 6 plus 5 equals 11. So there's something else you can do within RStudio if your console panel starts to get a little bit too messy, and I use this a lot personally when I'm coding myself or teaching a class. You can click this little brush icon and it will basically clear the console out. It doesn't delete the variables, it just clears like your working space. So if I was to go A again, you see that it's retained the value of 7 that we assigned at the very beginning of this lab. If you actually want to delete all the variables that we've declared, within the environments panel, you've also got this little brush icon as well. And if you click it, it'll come up with a warning. Are you sure you want to remove all the objects? If you click yes, you see now all the variables are gone. So now if I press A within the console and press enter, it can't find the object because we've cleared all the objects in our environment. So another thing we can do is create a script file, and a script file is effectively just a sequence of commands that RStudio will run in order of how we write it. So how we create a script file is we can go to File, New File, RScript, and as you can see here, it pushes down the console panel, and now we've got this text editor right above the console. This will basically be where we'll be editing the script file. So for example, in here, I can start typing some commands. So let's say we go A equals 7. So we'll be declaring a variable A, giving it the value of 7. And then the next line, I go B equals 8. So declaring a variable B and giving it the value of 8. And the next line, I'm gonna do print. Now the print command will basically just print whatever we put within inside these brackets. So if I go A times B, it's going to print to the console the value A times B, in which case 7 times 8 should give us 56. So what I can do is if I go Control A to highlight all of this and I click run, it's basically going to take everything we've typed in the script and dump it into the console line by line. So as you can see here, it went ahead to do A equals 7. It went ahead to declare a variable B equals to 8, and that's verified here in our environments panel. And the last line, which was print A star B, it ended up printing the variable A times the variable B and giving us that value, which is 56. And as we proceed with this course, we'll be doing a lot of stuff, drafting, brainstorming within a script file, and then running that within the console. So any tweaks we make will most likely be done in a script file from now on. So just keep that in mind. So before we continue with some more involved examples in R, we will need to install a package. A package is just like a library of features and functionalities that someone else has written and compiled and uploaded such that we can import into our installation of R and RStudio and use them without having to write them from scratch. So the package we're going to be installing is called lock5data. So how we can do that is within our console, if I go install.packages and then open brackets and put quotes here and type lock5data exactly like this, capital L and capital D, and press enter. If all is right, it should be fine. It may give you some warnings about which tools need to be installed by R directly, but that's okay. It will do its thing. And provided you've installed RStudio properly, the package lock5data should have installed no problem. Okay, now that we've installed lock5data, in order to use this package, the command is actually just library, open brackets, and then you type the package name. Now, RStudio is quite nice in that it's got some autocomplete functionality, and here it's just looking up all the packages that we've currently got installed. Most of these will have been installed by R as a default. Some of them had to have been installed when we decided to install lock5data, but this is the one we'll be using, so you can just click it, and it will autofill into the library function between the brackets. And if you press enter, and you get no errors, it means you've now imported the lock5data package, and now you can use it how you see fit. Now, why we wanted to install lock5data is because it comes with a lot of free mock data sets that we can use for some of the exercises we'll be doing throughout this course. So after doing the library lock5data command, which is something you'll need to do every time you boot up RStudio again and you want to be able to use the data sets here, we can go data, open brackets, and if you have a look here, because we've already imported the lock5data package, it's also gone ahead to have a look at see what data sets are now available because of that. And as you can see, if you scroll through, there are a lot of data sets that we can use. So just for the sake of this example, let's say we pick the all countries data set. Now you can type quotes, all countries, close quotes, or you can select it from the drop-down menu. Either one works, and you press enter. Now, as you can see here on the right-hand side, we've got this little promise between two tags and it hasn't been evaluated yet. The way you can force the evaluation, you can just click the promise word and it will go ahead and what's called resolve that promise. You don't have to worry about what that means. I just thought I'd let you know what that actually does. But if you click it, you see now it's loaded in the data set for us into our RStudio session. And it says here we've got 217 observations of 25 variables. Now, if you think back to the last lecture where we talked about cases and variables, cases are going to be just the rows within the data set. Now, if you look here, each row represents an observation, basically just a data point, and the columns represent the variables, so the things that we're trying to measure. So, for example, in this data set, if I was to click this little left-hand arrow, it gives us all the variables. So we've got country, land area, population, density, GDP, etc., etc. Like I said, this is just a mock data set that we'll be using a lot in the exercises as we go on through this course. And this is just one of the data sets we've got. Okay, now that we've imported the log5 data package and specifically using the all countries data set that it provides, we're able to now start looking at how we can view that data. So some of the functionalities we have at our disposal is if I type the command head, H-E-D, and then open brackets and type the data set that we have here, all countries, or just select it from the drop-down menu, and I press enter, the head command actually goes ahead and displays the first 6 rows of the data set. So the first 6 observations that we have out of these 217. Another command that we have at our disposal is the dim command, or dimensions, and this will give us the dimensions of our data set. So if I go dim, open brackets, and then all countries, and I press enter, this will give us the number of rows and columns that we have. Now, we could have easily just looked over in this right-hand side environments panel and it would have told us that already. But if you were to not have this environments panel for whatever reason, or you're using R alone without RStudio, and you want to see some of the almost like metadata of your variable, then this will be something that you could use. So here, if we type dim all countries, it says that it's a 2-dimensional array, and it has 217 rows and 25 columns. And that pretty much matches up with what we've got here. 217 observations and 25 variables. Something else very useful too, if you're just concerned about some more analysis type of functionality, is if we use the command called names and then open bracket the dataset name, so all countries in this case, and I press enter, this will just list all the variables of the data set. So if we click this little arrow again, you see that we've got the variable names listed here. But if you just want to see it within the console, this will tell you what they are. So here we've got country, land area, population, etc., etc. Okay, so the next functionality we're going to be introducing is taking a random sample. Now, this is actually really handy because it effectively goes back to what we said in the last lecture about how randomized sampling is one of the most powerful ways that we can make inferences about our data, specifically about associations and causations. Now, how we do that random sampling, it can really depend on what it is that you're doing and how you're trying to implement it. So within R, we've got a really nice command for that, and that's just the keyword sample. If we just do the keyword sample, and I go, for example, 1:10 and 10, it's saying, give me 10 random numbers between 1 to 10. So the general syntax with how this command works is it's going sample, min, max, n. I haven't declared the variables min, max, or n, but I'm just trying to write this here so you guys can understand what's going on. Like I said, this command here is saying, give me n random numbers between min and max, and they can be whatever it is that we declare. So in the example above, we're saying, give me 10 random numbers between 1 to 10. We can do something else like sample 2, 20, and 5. This is saying, give me 5 random numbers between 2 and 20. And if I press enter, it's given us 5 random numbers between 2 and 20, 6, 4, 16, 18, and 11. But we're not restricted to just doing the sample command using this notation here, number, number. We can also do it on variables as well. So let's say I create a variable called GPA, and it's going to be a set of numbers, and let's say it's going to be 2.9, 3.0, 3.6, 3.2, 3.9, and one more value, 2.8. So we have a variable now called GPA, and it's a set of 6 numbers. And let's say I wanted to grab a random sample of 3 from this variable here. All we have to do is use the same command as we used above, sample. But instead of typing in a lower number and a higher number, we can just type the variable name GPA. And I said I wanted to extract 3 of them. So the second argument is just going to be 3. And if you look at this now, it's given us a random sample from GPA, and it's given us 3 of them. So it's plucked out the number 3, 3.2, and 3.6. So something else I also want to touch on, and I probably should have done this earlier, but still not too late, is you can actually access certain elements within a set of numbers. So with the GPA variable that we had before, if I just press enter, as you can see, it's a set of 6 numbers, an array of 6 numbers. If I wanted to access the first element, I would type the variable name GPA, square brackets, and if I give it the number 1, it's going to grab the first element. If I do number 2, it's going to grab the second element, number 3, the third element, etc., etc. So if I wanted to grab the third element, which would be 3.6, I would go GPA square brackets 3, and I press enter. As you can see now, it's returned 3.6. So some of you may be wondering what would happen if I tried to access the 7th element, for example, because GPA only has 6 values. So what happens if I try to do the 7th element? It gives us NA, which is effectively non-applicable because this variable doesn't have any values beyond 6 entries. Something else to note is that other programming languages start their indexing at 0. R starts their indexing at 1. So what I mean by that is to access the first element, you just have to type 1 as the index. So like I said before, if I want to access the first element, I go GPA square brackets 1, and that'll give me the first element. Some other programming languages like C are what are called 0 indexed. So they get their first element by using square bracket 0. But for this course, you don't have to worry about that. I just thought I'd bring it up in case you were curious. So the GPA example that we gave here was what's called a one-dimensional array because we've only got 6 numbers and they're just kind of going left to right. But the all countries data set that we imported earlier, that's a 2-dimensional number array because we've got 217 rows and 25 columns. So how do we go about accessing elements in there? So as an example, if I type the variable name, which is the data set all countries, if I go open square brackets, if I go 1, then comma, this is going to give me the first row and it's going to give me every single column. So if I press enter now, you see that it's given us the first row and it's brought back every single column value or every single variable value. It brought back country, land area, population, density, etc., etc. But what if we wanted to just say access the population value from the first row? We can just do, I can just do all countries, square brackets, first row, and if we count left to right, 1 is countries, 2 is land area, 3 is population. So the third variable is actually population. So if I type the number 3 here and I press enter, you see that it's given me this value here, 30.552, which is the first row's population value. You can also do things the other way. Let's say I wanted to bring back all the population values. Well, we know now that population is the third variable. So if I go all countries, square brackets, now I don't type anything for the first variable, the first entry. So I just go comma. So nothing, comma, and if I type 3 now, it brings us back every single entry for that variable now. So it's gone through and did all 217 rows and it's brought back the third variable value, which is the population value for all of those rows. Now, in order to bring back multiple rows, we can do something like this. If I type all countries, square brackets, let's say I want to bring back the first and the third row, I can go C, because this, remember, this will create a number array, and I go 1, 3, and then I press comma again outside of the circular brackets. So this is saying, give me entries 1 to 3, and bring back all the variables. So if I press enter now, it's gone ahead and just given us the first row of the data set and the third row of the data set. If we wanted to bring back the first 4, we can do something really similar. So if I go all countries, if I go open brackets, now instead of typing C, I can do 1:4. Hopefully you remember that example from before. And then I press comma. So this is saying now, give me every single row starting from 1, going all the way to 4, and give me all the variables. So now if I press enter, you see it's gone ahead and grabbed the first 4 rows from this data set, and it's given us all the variables back. So now, given everything we just talked about, we can actually proceed with grabbing a random sample from a data set. So with the all countries example that we just had now, let's say I wanted to grab a random sample of size 10 from all 217 rows of this data set and bring back all the variables. We can do something like all countries, the name of the data set, square brackets, and using the sample command again, I want to say start from 1 and go all the way to 217 because that's how many rows we've got in our data set, comma, and I want to bring back 10 of them. But we're not done yet. Remember, all countries is a 2-dimensional data set, so I have to press comma here to indicate that we want to randomly sample the rows and bring back every single column from that random sample. So now if I press enter, it's gone ahead and brought back 10 rows of the data set, and it's brought back all the associated variables along with it. Now keep in mind, if you were to do this command again, and a shortcut you can do that in RStudio is if you click on your console and press the up arrow on your keyboard, it goes back to the last command that you executed, and you press enter again. You notice that the data set that it brought back is different, and it should be because it's meant to be a randomized sample. If you wanted to do that in a little bit of a more programmatic way, instead of just reading off 217 from this environments tab, recall that we have the dim command. So if I set a variable called size, and I set that value equal to the dimensions of our data set, if you have a look here now, a variable called size has been declared, and it's an array with 2 numbers, 217 and 25 as the first and second elements respectively. So what I can do is now when I do the same command as we did above, the all countries samples 1 to 217, instead of typing 217 here, I can delete that. I can use the size variable that we had earlier, and then square brackets because it's an array of 2 numbers, and just type the number 1. Size square brackets 1 will index the first element in the variable size, which is just 217, and everything else is the same. And press enter. It's given us 10 random rows from this data set and brought back all the variables. It may seem a little bit more complicated, but the reason I recommend doing something like this is because then you're not having to rely on reading something visually, and you're just doing everything programmatically, and it just kind of helps you develop better habits, I suppose, as a programmer as you go forward. Something else that I forgot to mention is that, like you recall before, if I do all countries, square brackets, comma 3, this will return everything in the third variable column, which was the population. If you don't want to do this, or you know what the name of the variable is, so for example, if I click on this arrow here, it's listed out the variable names. If we type the dataset name and then go $, you see now it brings up all the column names, all the variable names. So if I select, say, population, which was the third one, and press enter, it's gone ahead to list out all the population values as well. So it's the exact same thing as going all countries, square brackets, comma 3, because it was the third variable. Now, depending on what our application or purpose is, we may end up using one or the other, but there's a good chance when we're trying to analyze the data, we'll just be using this notation instead. Dataset name, $, variable name. And keep in mind, this is, again, case sensitive. So if I go all countries, $, population, but lowercase p, you see that it auto-corrected it there for me. But if I forced it to do lowercase p and I press enter, you see that's given us this null value here. It's because it didn't find population variable with a small p, it has to be population with a big P. Like I said, everything we do from now on with programming is case sensitive, so keep that in mind. Okay, now we're ready to move on to the very first exercise of this lab. You have a group of 5 people and their ages are 19, 22, 21, 19, and 24. Write an R script that will store the ages and also calculate the average age for this group. So have a flick back to what we just talked about with variables, declaring a set of numbers and mathematical operations. Come back to this point, pause the video, give it a go, and when you're ready to see the solutions, unpause the video and we'll proceed. Okay, so now let's go ahead with the solution, and this is basically how I would approach a problem like this. So the problem stated that we have a group of people and their ages were 19, 22, 21, 19, and 24. And the first part of the task was to store these ages in R. So the way we do this is we can create a variable here called ages equals. Now remember to create a list of numbers because we've effectively just got 5 numbers that we need to store. We use the C command, so C open brackets, and we just type the numbers that we need to store. So the ages were 19, 22, 21, 19, and 24. Now if I want to make sure this runs with no problem, and it's good practice to do this as you go, as you write your script, you can just highlight this line and click run, and it will run it in the console. And as you can see, we now have a variable called ages, and it stored the numbers 19, 22, 21, 19, and 24, and it ran with no problem, so it's a good start. And the next part of the task is to find the average of all these ages. So I will show you sort of the naive way of how we would do this, because I know for a lot of you, this may be your first time programming. So don't be afraid. I will just lay it out as how one I think would do it as a beginner, and then I'll show you some of the more advanced functionality that you could do. So with the more naive approach, what we could do is we just take all these numbers that we've given here in the ages variable and just add them up and then divide by the total number that we have, because that's the definition of an average. So I can do something like this. I'll declare a variable called average and equals. Now I'll open up a bracket because I want to add up all these numbers first. So 19 plus 22 plus 21 plus 19 plus 24, and then divide by however many people we have, which was 5. Divide by 5. So now if I highlight this line and click run, you see that it ran with no errors, and the average it gave us was 21. And that's pretty much the task done, but the naive way of doing it. Okay, so how I would approach this in a little bit more of an advanced way in regards to using the functionality that R gives us. We can first add the total up of all these ages and store them in a variable. So I can go something like sum of ages, again, trying to adhere to the variable naming standards. In this case, I'm using what's called camel casing. So sum of ages equals 19 plus 22 plus 21 plus 19 plus 24. I wouldn't even do that because R actually has a really nice functionality that we can use, and it's called the sum command. So if I go sum and then open brackets and provide the variable, this will actually go ahead and provide the sum of this set of numbers for me. Because as you can imagine, let's say we had the ages of 1,000 people or 10,000 people. Typing each of those individually would be a pretty big nightmare. So using some functionality that R provides for us when we can do it is going to save us a lot of headache. So I'm going to declare a variable called sum of ages, and it's going to be equal to the function sum on the variable ages. So if I highlight this line and click run, as you can see, it's gone ahead and given us a variable called sum of ages, and the value is 105. It's gone ahead to add up 19, 22, 21, 19, and 24. And we can actually verify that here. If I go into the console now, highlight this sum that we had earlier and press enter, it's given us 105. So that's the first thing that we can do. The next thing we can do is, instead of visually seeing that there's 5 elements, there's actually another command that we can use. And it just gives us the total length of a one-dimensional set of numbers. So if I declare another variable now called number of people, and I set this equal to length of ages, the length command actually just grabs the number of elements that we have in this set of numbers. And this only works if you have a one-dimensional set of numbers. If you have the two-dimensional case that we had with the all countries dataset, just use the dim command that we had before. So now if I highlight this line and click run, as you can see, number of people has been declared as a variable, and the value we have is 5. So if I now type number of people into the console and print, it gives us the number 5. So now we've got these two different variables, sum of ages and number of people. We can go ahead and calculate the average age, which by definition is just the sum of all the elements divided by the number of elements we have. So it's pretty much doing this exact same average thing that we did earlier, where we manually added up all the numbers and divided it by the total number of elements. But now we've got them stored inside neat variables. So we can do something else like average, again, as the variable name, equals sum of ages divided by number of people. And if I run this line and click run, as you can see, it ran with no problems and it gave us the exact same average as we had before, which is 21. But hopefully you can see now that this second approach is a lot better and quite frankly, a lot cleaner, because we've tried to be smart with some of the variable names. And if you were to read this, even if you weren't too savvy with programming, you should be able to see just by the names of the variables and try to infer what these commands do. You'll be able to see what it is that you're actually doing. So there's one more thing I want to touch on before we proceed in regards to writing a script file within R. It's just a general programming concept that I should cover, and it's called comments. They're just text that you add into your programming file or your script file such that they're not actually run by whatever it is that you're writing in, like the language. It's just something that you use to kind of remind yourself of what you did at this point. So there's no real way to do comments. It's just whatever you think will help you prompt your memory. So using this example script file that we have here, the first line I can say, and the syntax for writing a comment varies with every language. In R, you type the hash symbol, so shift 3, and then here I can start typing any random stuff, and you see that it's highlighted in green. This means it's a comment. So like I said, this isn't actually run by R, it's just for pretty much our use to remind ourselves of what we did before. So for the first line, I can write something like declaring the ages and storing them inside a variable. I can space this out, do another comment here, getting the sum of all the ages. I can do another line here, getting the number of people we have as another comment. And the last comment, we can do something like calculating the average. So like I said, the comment here isn't actually run as code. It's just text that we use to kind of make clear what we're doing. And it's a good habit to get into, to add comments, because you might write this now and in 3 months time, you may want to come back, and what may have seemed obvious then may not necessarily be obvious now. So having little comments here and there, like what I've done here with having a comment for every line, is quite excessive, but just having reminder comments here and there is going to help you remember things so much easier. It's also a good practice as well, because if you were to share your code with other people, how your logic and how your thinking may be could be very different to how someone else may think and do things. So having little comments here and there will kind of just make their life a bit easier when they're trying to read through what you did. Okay, so now let's move on to the second exercise of this lab. This one's going to be a little bit more involved because we're going to be using the Lock5 data package, but hopefully it's not too bad. So the first task is to load the dataset student survey from the Lock5 data package. The second task is to display the number of cases and variables in the dataset. And the third task is to take a random sample of size 10 from the dataset student survey and show the values of the variable weight for all the cases in your sample. So once again, have a look back to how we imported the Lock5 package, how we imported one of the data sets from that package, how we access variables, declaring random samples. And pause the video at this point, give it a go, and when you're ready, unpause the video and have a look at how we do it. All right, so let's get on to the solution for this second exercise. So the first step was to load the dataset student survey from the log5 data package. So first thing is first is we want to import the package first. So in our script file, I'll type the word library and then bracket log5 data. Remember, we need to do this every time we start a new R or RStudio session. So it's just good practice to write this line first if you want to use a package. That should be the very first thing you do. The second line will be to import the dataset student survey from the log5 data package. So the command was data. And then as you can see, it brings up all the packages, all the data sets within the log5 package. So I can scroll down to student survey or just start typing and let it autocomplete. Now, we want to verify that what we're doing so far is good. So I'll highlight these two lines and click run. As you can see, we got that promise evaluation issue again. We can do two things. We can either wait for it to evaluate, click it to force it, or the other thing that we can do is in your script file, you can just type force, and then if you have a look here in the console, it actually does it for us when we click the promise word to resolve it. So we can actually type force student survey, and then that way, whenever you import the package, import a data set, and you type the force, it will always kind of render in some ways. So I will also add a comment up here, just so it's clear what we're doing. So we're loading the log5 data package and importing the student survey dataset. Once again, comments are just up to you, but I like to try and make my comments as clear as possible when I'm coding. And as you can see, I didn't do it for every line. This group of commands is effectively just this bit here. Okay, so the next part is display the number of cases and variables in the dataset student survey. So add a comment, displaying the number of cases and variables. So we can just go ahead and use the dim command again, but because I know the next part will need to take a random sample from it, I will store this in a variable. The number of cases and variables I'll store within another variable. So I will type the word size again as the variable name equals dim, which is dimensions, open brackets of the dataset name, which is student survey. Now, if I highlight this line and click run, as you can see, it's gone ahead to create a variable called size, and it's gone ahead to also store the dimensions of the dataset in the variable. So 362 rows and 17 columns, which is good. Now, the third part says, take a random sample of the dataset student survey of size 10 and display the values of the variable weight for all the cases in our sample. So there's a few parts to this. So the first thing we're going to do is take the random sample of 10 from the student survey dataset. Now, if you think back to what we did earlier, the keyword we're going to be using is sample. So what I'm going to do is declare another variable because we're going to be using that later on. So I'm going to type this as the variable R for random sample, or RS, but R is fine. So R equals student survey, because that's the data set, square brackets, because we're going to be grabbing a random sample of 10. So 10 random rows. So the keyword here is sample, open brackets, 1, colon. Now we need the full scope of the student survey dataset in terms of how many rows we have. We have 362. We can just type 362, but if we want to be a little bit more programmatic, remember the variable size stores the dimensions of our dataset, and the first entry is the number of rows. So I can type here size square brackets 1. And this will effectively take the 362 value and put that here. So now I'm sampling across all the rows in our data set. So that's how many rows we want. We want 10 random rows. Oh, almost forgot. So we want to sample from 1 to the the max of the student survey rows, comma, and we want 10 of those. And once we have finished off this bit, that is the number of rows we'll be sampling. And if I press comma, this will, remember, bring back all the variables for this data set. So now if I go ahead and run this, as you can see, it's declared a dataset variable now called R, and we've got 10 rows and 17 variables. So this will be the 10 this random sample of size 10 that we generate. So if I go into the terminal and type R and press enter, you see it's gone ahead to give us the random rows that it grabbed. Now, if we just want to display the weight variable, so this will be the next step, display only the weight variable from our random sample. The way we can do this is, remember, we can use the $ for when we have a data set, and if we go $ after it, we can then choose the variable that we want. So if I go R $, you see that it's now bringing up all the variables that were the same, that were in student survey, but R is just a smaller sample of that. So it should have all the variables because we didn't tell it to filter on anything here after this second comma. So if I go R $, it's given us all the variables that we want, and we can just type weight or just select it here. And if I run this now, as you can see, it's given us all the weight values from our random sample. And if I have a look at the full random sample here, you see it's all the weight values. So if I scroll down a bit, hang on, make this window, hang on. Yep. So the first value was 183, which is this one here. Sorry, I got chopped off. And then we've got 195, 110, 150, etc., etc. As you can see, it's doing exactly what we wanted. All right, hopefully you enjoyed the first lab/practical for this course. It was a lot to take in, especially if you're new to programming, but don't worry, programming is a learn by doing type of venture. So the more you do it, the more you fiddle around with RStudio, the more comfortable you'll become with it. If you have any questions, please don't hesitate to leave me a comment down below, and I'll try to get back to you as soon as possible. And the next lecture will be on describing data. So the shape and center, the measures of spread, outliers, box plots, how we relate variables together. Should be some fun stuff. So I'll see you all then. Bye.